Okay, so we are going to be looking at area and perimeter in the context of real-life situations, which at first glance are going to appear to be word problems. But no fear, we're going to use UPSCheck and work through these pretty simply. So, UPSCheck will work every single time in math that we need to do a word problem. So just to recall, we're going to understand by underlining important information that they give us. We're going to plan it out with a picture of some sort, and then we're going to be able to use these two steps to know how to solve. And then, of course, finally, we'll check our work. So, we're going to jump right into this. Feel free, after I've gone over a few examples, if you want to start pausing the video and working through them yourself before I go over them. That may be a good way of practicing along the way. Otherwise, then you can work through all the examples with me, and then at the very end I have 4 problems that I'm not going to go over. I'm just going to show them to you and then give you the answer. So if nothing else, you'll get some practice at the very end. Logan wants to decorate the outside edge of his desk with duct tape. His desk is 2 feet wide and 2.5 feet long. How much duct tape will he need to buy to go around the edges of his desk? So the important things here would be that we're going on the outside edge of his desk, and his desk has the dimensions of 2 feet wide, 2.5 feet long. And again, the question is asking me, how much will it take to go around the edges? So I'm going to plan that out. I've got his rectangular desk. It is 2.5 or 2.5 feet wide, and 2 feet, or 2.5 feet long, 2 feet wide. And now I've got to figure out, based on the information they've given us, whether I want perimeter, area, or volume. Now, if I'm putting the duct tape around the edge of my desk, then that would, of course, be perimeter. So I am going to add all the sides. Now, something that a lot of 5th graders get tricked on here is that they only add the 2.5 and 2. But if you do that, you've only put duct tape around half the desk. If you want to go all the way around, you need to fill in the missing sides, which would give you a total perimeter of 9 feet if you add up all those edges. Alright, next problem. Bobby's rectangular yard is 350 feet long and 205 feet wide. How much fencing will he need to buy to go around his entire yard? So we've got a rectangle yard, we've got the dimensions given to us, and this time we're talking about putting fencing around our yard. So once again, I'm going to plan it out. I'm going to label the information they've given us. And now I'm thinking, do I need perimeter or area? Well, if I'm putting a fence up, I'm going to put the fence around the outside edges. So this is another example of a perimeter problem, which means I'm going to need to know these missing sides. I don't want to just add 350 and 205, because then I won't have put a fence all the way around the yard, and that cute new puppy will run away if I don't fence in the whole yard. So our total there would be 350 and 350, 205 and 205, which should give us a total of 1,010 feet of fencing that we will need to purchase. Alright, next up, we have a chart here. Charts are a great start to our planning. The chart shows the dimensions of 4 different rectangular trampolines at Jumpology. Which trampoline covers the most floor space? So we've got all of these are rectangles, so I could draw them out. Trampoline A, B, C, and D. And then I could label them with the length and width that they've given us. So 10 by 10, so that's actually a special rectangle known as a square, because if this is a 10 by 10, then that means all sides are technically 10. The trampoline, 12 by 8, 11 by 9, and 9 by 10. And now we need to figure out, we've got a great picture going, what do they want us to do? Which trampoline covers the most floor space? Well, if I'm talking about how much space these cover, I'm talking about the area that they cover. So how many square feet of flooring that they're covering. So basically I would be using my length times width formula since they're all rectangles. And I'm looking for the one that covers the most. So a 10 by 10 would give me 100 square feet of space. 12 times 8 would give me a 96 square foot area. 11 by 9 would give me 99 square feet, and 9 by 10 would give me 90 square feet. So if I'm answering the question asked, I would want to choose trampoline A because it covers the most square feet. It's kind of like a little multi-step problem there. Alright, next we have a triangle, a tricky triangle. Alright, Sue is forming a triangular garden in the corner of her yard. The dimensions are shown below. How many square feet of soil will she need to buy for her garden? Now, they've already done some nice planning here for me. They've shown me her triangular garden. They've given me the lengths of the sides. Now, I need to figure out what they want me to do. If I'm talking square feet, I want to know how many squares I would cover this triangle in. And another way of thinking about it is soil. Soil doesn't just go around the edges or around the perimeter. That doesn't make sense. Our soil needs to cover all of that area so that we have a place to plant our seeds. So, if I want to do the area of a tricky triangle, it is tricky because I have to remember it's not just length times width, it's also divide by 2. This is a formula that in 5th grade you're expected to memorize. In 6th grade they give you a formula sheet. But for now you should know the area of a triangle is length times width divided by 2. This is another kind of tricky part on a triangle. A length times width is always easy on a rectangle because it's always just one side times the other. But with a triangle, you've got to actually use the two numbers that form that L, that form that 90-degree angle. So in this triangle, we're actually not going to use the 10 for area. We're going to grab the length and the width, 4 and 6, because we're using this right angle right here. I always say find the L. If you're doing length times width, one side times the other, find the L or the 90-degree sides. So you would be doing 4 times 6 divided by 2, giving you an area of 24 feet squared. Oh, sorry. Forgot to divide by 2. See, it's a tricky triangle. 12 feet squared for our garden. Don't forget to divide by 2 like I just did. Alright. Next up. John's yard requires 180 feet of fencing. Which of the following should be the dimensions of his yard? Now, this one's a little interesting. This one's kind of like a working backwards problem. We know that his fencing is 180 feet. That means that the perimeter of his yard is 180 feet. And we're saying if these are the dimensions of his yards, which one will give you the correct 180 feet of fencing? So you've got 4 rectangular yards, and you've got to label in the dimensions. Don't let these X's or these multiplication symbols throw you off. It does not mean to multiply. This is just how people say dimensions. So for example, if your parents have ever ordered pictures for picture day, sometimes they order like 5 by 7s of you or 8 by 10s, or if you're buying a rug for your room, maybe a 5 by 7 or 8 by 10. Those are just the dimensions. These don't mean times. So that's just how we write the dimensions of our rugs. So this would be 35 and 55. B would be 50 by 25, 35 by 30, 40 by 20. And we want to know fencing. So fencing again is perimeter. So I need to find the perimeter of all these shapes. So of course I don't want just 35 and 55. I've got these other missing sides that I need to fill in, which some of you with some good number sense would know that you could just add your 2 numbers and then double them for each rectangle, but that would confuse some of us. So sticking with adding all sides for perimeter is a safe way to go. And I would just type all these into my calculator, add all the sides, and I would find out that yard A is going to give us a perimeter of 180 feet. So it's kind of a tricky one if you go through, but this one would be 150 if I calculate the perimeter. This one would be 120 feet. So that's how you can kind of go about doing this. So A would be the one with the magic number of 180 if I add those up. All right. Moving right along. We have one final problem that we're going to do together before I give you guys some quick examples. And this one is kind of a lengthy one. When you glance at it, you're thinking, oh my goodness, this isn't a word problem. This is like a whole word story. And it's about our lovely Mrs. Ramsey, our math specialist at South. And so we're going to go through this using some really special UPSCheck. Miss Ramsey's going to decorate the windows of her home with Christmas lights. She has 7 windows on the front of her home. I like to plan as I go. You guys know that. I like to kind of do these UMP steps together as I go. So I've understood she's got 7 windows, rectangular windows. So I'm going to draw 1, 2, 3, 4, 5, 6, 7 windows. 6 of those windows are 3 feet wide and 5 feet long. So I'm going to go ahead and label 3 by 5, 3 by 5, 3 by 5 for 1, 2, 3, 4, 5, 6 windows. And then her other window is 5 feet wide by 4 feet wide. How many feet of Christmas lights will she need for her window? So I'm looking at how much light do I need to go around her windows? Because you've got to think, Christmas lights, where do people put them? They don't cover their window with them. They just put them around the outside edge, which tells us I need the perimeter of all these rectangles. Now, 6 of them are going to be the same. So technically, a lot of you will probably be able to calculate the perimeter of 1 and then times that by 6 windows. So if I calculate the perimeter, 5 plus 5 plus 3 plus 3, every one of these windows has a perimeter of 16. Okay, so that is going to give me a total of, again, you can type this in your calculator, but that's going to give me a total of 96 feet of Christmas lights, I believe. Please check me with a calculator if I'm wrong. And this window over here is going to be 5 and 5 plus 4 and 4. This window is going to need 18 feet. So that means that together, for all 7 of these windows, she is going to need a total of 114 feet of Christmas lights. And again, check my math, but that is how I solved it based on my understanding and planning. Feel free to check me with a calculator and comment on my video if you need to. Thanks. Alright, so the last 4 are not ones that I'm going to go over with you. These ones I'm just going to show you. I want you to read it, pause the video, work through it on your own, and then when you hit play again, I will be flipping this over so that you can see the correct answer. So I'll just hold that there so that you can see it. Work through that, pause the video and work through it. And now I'm going to be showing you the answer. So if you're not done, make sure you have paused the video. I'm sure you're not done that fast. Well, some of you might be. Alright. You should have calculated the perimeter and you would have gotten 144 feet total. Next, tricky triangles. Looking for which triangle. Oh, sorry, I'm not reading it to you. There it is. Read it, solve it. Pausing the video for as long as you need to. And the answer should have been triangle A once you did all that solving. Third example, similar to the jumpology question we did together. Now we've got Mary putting carpet in her house, in her home. Pause the video, work through it. Now I'll flip it over to show you the answer in a minute. And this should have said bedroom 3. I labeled my bedrooms wrong. This should say the living room, bedroom 1, 2, and 3. But bedroom 3 should have been your answer if you calculated the area correctly for carpet to cover the floor. Last but not least, we have a little bit of a multi-step one. Go ahead and read it. Pause the video, work through it on your own. And when you are done, you can check your work by looking at this answer. So your total should have been 1,240. Hope you've enjoyed it. Hope you've gotten some